All right, today we're starting Unit 8. Only this unit and then one more and then spring break. So it'll be here before you know it. Anyway, before we start Unit 8, there's a couple of things we got to review. A couple of things that are going to be really important for you to know. One is you need to know how to square a number on your calculator. I know most of you guys know how to do this, but if you don't know how to do it, it's important that you listen to what I'm saying or call me over to show you how to do it. So what I want you to do right now, just to make sure you know how to do it, is pause the video and tell me what 11 squared is and then what 23 squared is. And then play the video again to see if you got it right. And again, if you don't know how to do it, you need to ask me to show you, okay? All right, so hopefully you wrote something in there. If you want to square something, usually your calculator is going to have a key, whether you're using one of the yellow ones or the blue ones or one of your own or even your phone. Usually you're going to have a key like this x squared right here. So if I wanted to do 11 squared, I put it in 11 and square it. And so if you did 11 squared, you should have got 121 for your answer. If I did the same thing with 23, get 529. Okay, you also need to know how to take the square root of a number on your calculator. And I think there are more of you who don't know how to do this than that don't know how to square a number. So the square root symbol on your calculator will be one of those thingies. It doesn't always have its own key. Sometimes, like on the yellow calculators, you have to hit second first. There will be a key kind of in the upper left-hand corner that says second, and then you'll see like a green radical symbol to take the square root of something. So try to take the square root of 144, then try to take the square root of 1,000 on whatever calculator you're using. If you can't figure it out, let me know. So pause the video, do that, write a number in here and in here to make sure you know how to do it. All right, so if I want to take the square root of 144 on my calculator here, I'm going to do the radical symbol, 144. Oops, I guess I have to do that backwards. Okay, the square root of 144 is 12. I want to know the square root of 10,000. Be 100. So if you didn't know how to do that, if you still don't know how to do it, call me over and I'm happy to show you how to do it. But you need to know how to do that for Unit 8 because we're going to do a lot of squaring and square rooting. Next thing, and I know that we've already practiced this a lot, but we're going to be using the Pythagorean theorem, and so you need to know how to use it, right? And I know that most of you, if I asked, could tell me that the formula looks like this, but the important thing is knowing which side to put C on. You can't just put C here and A here and B here. You can't do that. So don't write that down. Right? C is always the side across from the right angle. So C is always the hypotenuse. The way you'll know you have the hypotenuse is if you're at the side that's across from the right angle, or you could think of it as the side that doesn't touch the right angle. Right? If here's my right angle, it touches this side and it touches this side, but it doesn't touch C. Right? So make sure you put C as the hypotenuse. And then the last thing you need to know for today's lesson is that an altitude in a triangle is a line drawn from the vertex, or from one of the vertices across to the other side, but perpendicular to the opposite side. So that would be one altitude of this triangle. I could draw two other altitudes of this triangle, but I'm not going to. Basically, the idea again is that you go from a vertex to the opposite side, but you make sure that you're perpendicular when you go to the opposite side. Okay, that's an altitude. All right, new material. First thing is, we just got done talking about altitudes, and the first thing new in this chapter is that if I draw an altitude line in a right triangle, so a line from a vertex perpendicular to the other side, or to the opposite side, like this, there's just a rule that says that when I do that, I've actually created three separate but similar triangles. The first one, obviously, is just the one that I started with, the big triangle, which I can call ABC. The second one I've created, you'll see this in a second, are the ones inside. Right? I've created this one right here, which now I need a new point. We'll call this point D right here. All right, so if I called this the big one ABC, I'm starting out here, I'm traveling along the shortest side first. So that's going to be my clue on how to write a similarity statement that now includes this sort of teal triangle. So if I start out at an angle and I travel along the shortest side first, this teal triangle would be ADB. And then obviously the third similar triangle I've created here is this one that I'm going to shade in green. Okay, how would I name that triangle? Well, again, I would start at B because I want to travel along the shortest side first. So I'm going B to D, and then the only point left to travel out to would be C. Right? So if I draw an altitude in a right triangle, I create essentially 3 similar triangles. And we'll see why that matters later. But for now, we're going to move into our next thing, which is the geometric mean. So mean in this case, whenever you hear mean, it usually means like average. And so if I was just taking the arithmetic mean of 2 numbers instead of the geometric mean, this will be more familiar. Like if I want to know the mean of 10 and 16, let's say, what I would do is I would add those 2 together and divide by 2. 10 plus 16 is 26, divided by 2 would give me 13. So 13 would be the arithmetic mean, but that's not what we're doing here. We're doing something slightly different. We're finding the geometric mean. And the way you find the geometric mean, you can already see it on your note taker, is like this. I multiply the 2 numbers together, and then I take the square root of whatever that is. Okay, and you'll see why we care about the geometric mean shortly. But let's do some examples first so we can make sure we understand what we're doing here. So if I want to know the geometric mean of 4 and 9, I would just say the mean is equal to the square root of 4 times 9. So I go to my calculator here, unless you can do this in your head. 4 times 9 equals 36. And then I would take the square root of that, and it would give me 6. All right, so the geometric mean of 4 and 9 is 6. Let's do it with these 2. I should say y. Okay, the mean of 7, the geometric mean of 7 and 24 is going to be the square root of 7 times 24. 7 times 24 is 168. I take the square root of that and I get 12.96. So the geometric mean of 7 and 24 is 12.96. I want you to pause the video. You try this last one, 12 and 19. So don't wait for me. Pause the video. Use your calculator. Figure out the geometric mean of 12 and 19, and then restart the video to make sure you got it right. Okay, so if I'm doing the geometric mean of 12 and 19, I would just put those 2 numbers multiplied by each other under a radical symbol. I would say, well, what's 12 times 19? That gives me 228. Square root of 228 is 15 point, let's just call it 15.1. Okay, that's the geometric mean as opposed to an arithmetic mean. Okay, why do I care about the geometric mean? What was it actually going to do for me here? Well, here's what. When I draw an altitude in a right triangle, right, like this red line right here, you'll notice that it splits the hypotenuse into 2 parts, right? Hypotenuse, why is this the hypotenuse? Well, because it's the side that's across the triangle from the right angle. Okay, so an altitude line, this red one right here, splits the hypotenuse into 2 parts. The length of the altitude, or what I'm calling x right now, x is just equal to the geometric mean of the 2 parts of the hypotenuse that altitude created. So x is going to be equal to the square root of 4 times 14. So 4 times 14 is 56. And then if I take the square root of 56, I get like 7.48. And so what that means is that x right here is about 7.48 units long. All right, let's do some examples that'll help you with the classwork. 2a here, well actually on 2a and 2b, I'm supposed to just identify the similar right triangles. And so what I was saying earlier is that when you draw an altitude like this or like this in a right triangle, you create three separate triangles that are all similar to each other. So the way I would do this, I start with just the biggest triangle, right? The triangle that we start with here. And you can start with any letter you want. I'm just going to go left to right. So I'm going to say the first triangle, the original triangle, is KML. And when I write a similarity statement, when I look at the two smaller triangles that I've created, I have to go in the same order, right, from point to point. So if this is my next triangle, I'm going to do the small one. I've got to look at where I started on the big triangle. And I started with this angle right here, right? So the way I think of it as K in the yellow triangle is the second biggest angle. All right, this angle over here would be a little bit smaller than K, and then obviously M is 90 degrees. So when I start to do name the green triangle here, I have to go to the second smallest angle. Well, in this case, it's going to be K again, right? P is going to be the right angle. M is going to be a little bit smaller than K. Okay, when I started at K, I went to M, so I traveled along the shortest side of the triangle. So when I go to my second triangle, the green one here, starting at K, which way do I go? Do I go along the hypotenuse, or do I go from K to P? I'm going to go from K to P, because if I travel along the hypotenuse, I'm traveling along the longest side of that triangle. After I go K to P, my last stop is M, and I have one triangle left to name. That's going to be this one that I do in blue here. So what's the second largest angle inside the blue triangle? In this case, it's going to be M. So I'm going to start with M. I'm going to travel. I have two options. I can go to P or I can go to L. The shorter path would take me to P, and then lastly to L. So the similarity statement, the three similar triangles here in 2A would be triangle KML is similar to triangle KPM, which is similar to triangle MPL. 2B, same thing. I'm going to start with the big triangle, which I'm just going to name triangle QSR. That's going to be similar to this little tiny triangle here. So where did I start on the big triangle? I started at the smallest angle, right? I started at the smallest angle, and then I traveled along one of the longer sides, but that's not the hypotenuse. So which is the smallest angle here in the green triangle? Well, it's S. And then I traveled to the right angle, and so the right angle in this little green triangle is going to be T, and then the last point there would be R, and that's going to be similar to this blue triangle right here. Where's the smallest angle in the blue triangle? Well, once again, it's at Q. I travel along the side that's not the longest, not the hypotenuse, so I would go from Q to T, and then lastly out to S. Okay, on these ones, I'm actually going to find some variables. So it says we're going to use the geometric mean theorem, but we're also going to use the Pythagorean theorem. Which we're more familiar with. All right, the geometric mean theorem means that if I draw an altitude within a right triangle, the two parts of the hypotenuse that the hypotenuse gets split into, the geometric mean of those two sides is equal to the length of the altitude. So if I look at this triangle here, I have x, y, and z I have to solve for. I see x is along one of the altitudes I could draw inside of the triangle KJL. All right, x is an altitude. And so the two parts it creates of this hypotenuse from J to K, one is 20 and one is 5. So the easiest variable to solve for in this triangle is going to be x, because x is going to be equal to the geometric mean of 20 and 5. And so I just put 20 and 5 under a radical symbol. I multiply them together. 20 times 5 is 100. And I know the square root of 100 is 10. So I'm going to go over here and in a different color, I'm going to just note that x here is 10. And then right here I'm going to write 10 because that might come in handy later if I know that that side is 10. It's actually going to come in handy right away because now what I notice is that I have this side right here, which is 20, this side right here, which is 10. So now I can solve for z. Now I'm going to use the Pythagorean theorem because I have two sides of a right triangle, and so I can use the formula a squared plus b squared equals c squared. As we've been practicing, a and b don't matter so much. I have to get c right. I have to make sure that the side that I put by itself is the hypotenuse. And the way I find the hypotenuse is the one that's across from the right angle. So if I rewrite this formula, I could say 20 squared plus 10 squared equals z squared. Right? 20 squared is 400, 10 squared is 100. Those two put together equals z squared. I haven't taken the square root of anything yet, so z squared has to say z squared for now. 400 plus 100 is 500, still equal to z squared. Now is when I'm going to take the square root of both sides. So the square root of z squared is just z. Square root of 500, I'm going to use my calculator, and it's 22.36. So z is going to be 22.36. So now I found two of the three variables. I'm going to come over here and I'm going to label this as 22.36. Now I just need to find y. Well, looking again at my triangle, what I can see is that I know this whole side is just 20 plus 5, and I know this side right here is 22.36. So y is just going to be one of the legs of a right triangle, so I can use the Pythagorean theorem again. Except, well, let's write it out. Again, a squared plus b squared equals c squared. Which side is going to be c here? Well, if I'm looking at the big triangle, which I am, the right angle is down here at L, and the side that's across from L is the side that I know is 25 units long. So C in this case is going to be 25. So 25 squared is equal to a squared plus b squared. I'm just going to say y squared plus 22.36 squared. All right, so now I just run the numbers basically. Y squared plus 22.36 squared is basically 500 equals 25 squared. Oops. 625. Okay, I want to get y by itself, so I'm going to subtract 500 from both sides of the equal sign. Y squared is going to be equal to 625 minus 500, which is 125. Now I'm going to take the square root of both sides, and y is going to be equal to the square root of 125, whatever that is, 11.18. So I found x, y, and z, and I'm done.